Hi students, welcome to the video lectures of software engineering. So today's topic is about specialized process models. So till date we have discussed general models in detail, and now we'll try to talk about specialized process models. So what are these specialized process models? So basically the specialized process models are tailored for specific needs or industries, which means these try to focus on some specific types of projects. These focus on specific types specific types of projects or industries, let's say. Okay, wherein these will try to adapt the software development process to address a particular need or a particular requirement. Clear? And we'll just try to understand this specialized process model using the examples. So the main point is the specialized process models are tailored for specific needs of specific industries. So examples, let us talk about these examples. First one is component based software engineering, right? We say this as CBSE or CBD sometimes. Okay, and second example is about formal methods. So what are these exactly? What are for this component based? So where the component based, when I say this component based, just try to understand there are a couple of components where we try to assemble the pre-existing software components, or we say sometimes as reusable building blocks. So to make it very clear for you, so this basically emphasizes on development of software using existing, well-defined and reusable software components, right? Precisely talking, component-based development is a reusable software engineering approach. Okay, this is also can be called as a reusable software engineering approach, right? So this is a reusable software engineering approach, we say, where it tries to emphasize on the development of software using the existing and well-defined and reusable software components. Clear? So what did you understand by this? So let me tell you clearly. So this is nothing but, or the key idea. So the key idea behind this component-based development is, let us try to build the software, okay, from the pre-built components rather than building the things from scratch. Okay, so build the software from pre-built components. Clear? Rather than rather than coding everything from scratch. Okay, so this is what is component-based software engineering is. Clear, students? So if we consider, let's say, these component, when I say these components, these can be, a third-party libraries or software modules, or even sometimes the entire subsystems, which are, the latter integrated into the final product. For example, let's say a large-scale enterprise system might use these off-the-shelf components for user authentication or payment gateways or messaging services. So rather than developing all these features from the scratch, because these particular things already exist and which we can take from the other, uh, you know, pre-existing software components. Understood. That is about component based. So, but when I say this component based, there are couple of things which we also should discuss. That is about the benefits, pros and cons. Okay, are benefits and challenges. What would be the benefits? Of course, the reusability is the biggest benefit what we get out of this, and the modularity, right? Modularity, because it encourages the better design and maintainability, right? That's another reason. One more benefit is faster development, right? Faster development. And one more benefit is reliability, right? Then what are the challenges that we have? Challenges are component mismatch, component mismatch. Then the other challenge is we have limited control. I'll talk about each one, don't worry. Limited control, and we have some versioning issues. It's very common in our software development. And the biggest challenge would be security risks. So let me start with the benefits. When I say benefits, first one is reusability. Yes, because we are trying to reduce the development time and cost, and we are trying to get already the pre-existing components, right? That is the commercial of the shelf parts. Then we talk about modularity. Modularity is because we have a better design And then faster development is we just try to not start everything from the scratch, right? So we just try to assemble rather than coding. Okay, we just try to assemble all the pre-existing components to make the final product. Next one is reliability. So why it's reliable? Because reused components are often tested and proven already. That is why it is reliable. Challenges are component mismatch, because sometimes the interfaces or the behaviors might not match our system needs. That is the reason why we say the components get mismatched. Then we have limited control. So when I say limited control, the source code for the components what we are searching for may not be available sometimes. That is why we say we have some limited control. This is one of a challenge that we face during in this particular component software engineering. And then versioning issues. What are versioning issues? Updating one component will break the other component sometimes. Okay, that is what versioning issues. Version like 1.1, 1.2 versions, right? We have software versions, right? Those things I'm talking about. Next is security risk, because of the reason that why we have security risk in these challenges is we are going to use some third parties, what we say, the components, right? When we start using some third party components, so these are highly prone to contain some kind of vulnerability sometimes, so because of which we also face some challenge. So hope you understood, students. This is all about component-based software engineering, or sometimes we say CBSE and CBD, component-based development. So then next we have the method, that is formal methods. So what are these formal methods? So formal methods are nothing but these try to involve some using some mathematical models to specify the design and verify the software systems. Talking precisely, the goal of this particular formal method is to improve the correctness and consistency of a system using some kind of rigorous mathematical techniques. Okay, so and especially this is useful in kind of systems where high reliability is critical. Okay, high reliability, when I say yeah, let's try to consider the example as aerospace, aerospace, or some kind of medical devices, medical devices, or some kind of any safety critical kind of softwares, right? So if you consider an example, let us take a flight control system where the airplane must use some kind of formal methods to ensure that the system will behave correctly and safely under all sort of circumstances during its journey from starting to ending. Okay, either it's from the departure to arrival or something, right? So those kind of places or the models where we try to implement these formal methods, which implements or which involves the usage of mathematical models to improve the correctness or the consistency of a system. Clear? That is about formal methods. So next we talk about the personal software process and team software process. So what are these things? Especially talking about these personal and team software process models. This always aims to improve both the individual and team performance in software development. See, PSP is personal software process, TSP is team software process. So when I say these both things, so the aim of both these particular process models is to improve the individual and also to improve the team performance when it comes to the concept of software development. It means these both models will focus on how the developers or and how the team can improve their overall productivity or quality and accuracy in terms of the software development. So now if we talk about personal software process, so this is focused on improving the individual software engineer's performance. It encourages self-management, measurement, continuous improvement by setting a personal goals and using metrics to track the progress. All right. So the personal software process is focused on improving the individual software engineer's performance. Clear. So for example, the developers using PSP, this personal software process, collects the data on their own activities, such as time spent on various tasks. Let's say how much time did we spend on designing, how much time did we spend on coding, and how much time did we spend on testing, all these things. And also sometimes when we does testing operation, so what sort of defects that we found during testing, and what is the quality of the code that we have written, and all these things falls under a personal software process. So if we consider the example, a developer might use this personal software process so to track that how much time did he or she have spent coding or versus debugging, and they just try to adjust the process in order to achieve the efficiency. And they specifically or precisely focuses on some kind of personal metrics to improve themselves as an individual in doing in this software development. And when we talk about the team software process, so the team software process builds upon, here you can see, the concept of personal software process, but applies them to a team of software developers. Okay, so this applies to the team of software developers. So when I say TSP, it encourages the teams to set a kind of clear goals, and they create detailed plans, and also they track their progress and continuously evaluate and improve their processes. In terms, every individual that who are there in the team also get improved because of all these metrics that they put on the team. And as a team, they evolve. Clear. So suppose the team software process will try to define the roles of every individual in the team, and they try to establish some objectives, and they try to collect the data on quality or productivity, and some kind of schedule adherence. Okay, so by doing all these activities, they identify their potential improvements, and what are the ways that they can optimize the teamwork and how better they can perform. All these things can be evaluated using these metrics. For example, let us say a team is working on a software project and they implemented this team software process. Implementing the team is nothing, team TSP or team software process is nothing but they try to have their own goals set, and they have their own detailed plans, and they have their metrics how to track their progress and achieve quality. Okay, so now when a team working on this particular software project using the TSP, so they ensure that each member knows the responsibility and monitors the progress through the metrics, whatever I said just now, and have kind of regular meetings to discuss the issues what they face and the improvements in their team, right? So in summary, if I say both the personal software process and team software process, either this PSP or TSP, both, okay, are about kind of self improvement and team optimization through various metrics like planning or a process discipline. So ultimately it should lead to a better software development practice and results. That is what the goal. Clear? So hope you understood the PSP and TSP. Then next we enter into another model called the unified process model. Clear? So what is a unified process model? So we'll talk about this. So it is an iterative and incremental process, and unified modeling language for design is used. So there are phases in unified process model, that are inception, elaboration, construction, transition, which focuses on use cases, architecture, and risk management. So unified process model is an iterative and incremental process model. Okay, which is iterative and incremental process model, which emphasizes, let me write this, which emphasizes use case, archi- architecture, and risk management. Okay, so this is what it emphasizes on. So this particular unified process model is introduced as a part of our UML. UML stands for Unified Modeling Language Framework, which is a standardized approach for object-oriented design and development. So the key phases in this are inception, elaboration, construction, transition. So what are these phases? Okay, so you can see the diagram here. These are the phases. So we already know what are these: communication, planning, modeling, construction, and deployment, where we gather the requirements and we plan everything with the available resources. Then we have a design of that. Then we try to implement or start writing the code and test it. When it passes testing, then we just deploy. Deployment is nothing but to deliver the software, right? And that is what is your unified process model. And the phases include, you can see here, there is one phase: inception, elaboration, construction, and transition. We'll talk about this. Inception phase is nothing but it's requirement gathering phase, we say. Okay, what are the key requirements we have to identify, and also it makes us understand what are the high level goals of the project, and also sometimes it performs the initial risk assessment. Not sometimes, every time it performs a risk assessment. So if we talk about an example, in case of developing a e-commerce application for mobile, okay, the inception phase would involve identifying some kind of key features like product listings, payment processing, and how to authenticate the users, all these things. And when I say elaboration, in elaboration phase, this try to focus on refining the architecture and design of the system. And also we try to work on high risk elements which are identified already. Clear? And also we have to ensure that the critical aspects of the system are addressed early. For example, in this phase, we would refine the mobile application what we're trying to build, the database of that application architecture, and also we try to take into consideration the performance and security, how this will be affected in the long run. And the next phase we have is construction phase. So during the construction phase, the main work of the building, the software is carried out now, which includes developing all the components or writing the code and implementing the system. So according to the design which is refined from the previous phase. Now it's time for the development team to focus on writing the code and also to include the core features like browsing, some shopping cart and checkout process or payment, whatever. Right. Next is the transition phase, we say. So the transition phase is nothing but it involves the testing and deployment phase, we say. Right. So you can see that is what is mentioned in the diagram as well, uh, where you also get feedback from the stakeholder and you try to finalize the system for release in this particular phase. Okay, once the application is built, so it goes through some rigorous testing and bug fixes, and then it is released to the users. Clear? So what are the main characteristics in this unified process model are? So first would be your use case driven. Okay, use case driven. Next is architecture centric. Next is risk driven. Right? When I say use case driven, the unified process, when I say focuses on defining the use cases early in the project. Okay, it tries to make the use case diagram, which we have already seen in our previous video lectures. These use actors and use cases and try to define them in the very early stage. Then architecture centric is it tries to emphasize on creating some kind of solid architectures. Okay, then risk driven is we try to identify early risk, and try to resolve that, so that the problems what we can face in the latter stages can be reduced, and we can bring out a very effective product. So that is about unified process model. Okay, so in summary, unified process is best suited for large scale projects, which requires a structured yet iterative approach. Clear? So hope you understood, students. Thank you.